Happy Friday, grade 10s. So today we are going to be continuing on with our understanding of position time graphs. So in our last class we were talking about how to draw a position time graph. That position is always on the y-axis and time is always on the x-axis. And we also talked about the slope of the graph representing how the object is traveling. So you worked on understanding that a straight line graph means that you have a constant velocity, that if you have a curving graph, that means the object is either speeding up or slowing down, so a changing velocity. We also talked about an object traveling in the positive direction is shown on a graph as the line going upwards, and if an object is moving in the negative direction, the line is going downward. So you're probably thinking, that's great, I'm understanding all of this about position time graphs, but how do I calculate the slope? So that's what we're going to talk about today. So the slope principle is that the slope of the line on a position time graph is equal to the velocity of the object. So we talked about that yesterday, that whatever the slope of your graph is, tells you the velocity of the object. So if you had a very steep line, you have a high velocity. If you have a shallow line, you had a low velocity. So we'll just look at this for example. Consider a car moving with a constant velocity of 10 meters per second, okay, for 5 seconds. So here we have on this little diagram, we see that we're traveling 10 meters every second, so we're traveling 10 meters per second, and then that's also graphed on our line over here. So if we know that our velocity is 10 meters per second, we also know that our slope is 10 meters per second. Another point we're going to look at is what happens when you have a straight line, and this is just kind of recapping what we did last class. This straight line is new. So if we consider a car moving at a constant velocity of 5 meters per second, so here we have this person traveling at 5 meters per second, and that's drawn on our graph as well, and then abruptly stopping and remaining at rest for 5 seconds. So if the position of the object isn't changing, we have a velocity of 0, meaning that our time continues, so we can see that time is still going on. We go from 5 to 10 seconds, but if we have no velocity, that means that our object is staying in its position. So here we can see that we went from a position of 0 meters to a position of 25 meters in 5 seconds, and then for another 5 seconds we had no velocity, so we just stayed at 25 meters. Okay, so a slope of 0 means that the object is not moving. So right here we would have a slope of 0, this is a completely flat line, the object's not moving. And it makes sense, because this position y-axis is telling us what our position is. So if we're at 25 and I tell you, or if you're standing 25 meters away from me and I tell you to stand there for 5 seconds, your position hasn't changed over that time period. Okay, so remember that one. On a position time graph, a straight line means that the object is not moving. So let's figure out how to calculate slope. So you have to have a good understanding of how to calculate slope so that you can figure out the velocity of an object when we're doing position time graphs. So some of you may have seen this slope formula before. It's also known as rise over run, y2 minus y1 over x2 minus x1, change in y over change in x. There's so many different ways to write it out, so whichever of these makes the most sense to you, you're welcome to use when you're writing out your equations. But let's go through the steps of how to calculate using this formula. So our first step is to pick 2 points on a line and determine their coordinates. So coordinates are the x coordinate, so wherever you are on your x-axis, we'll just pick 1 for example, and the corresponding y coordinate. So the corresponding y coordinate to an x of 1, if we go straight across, is a y of 10. So the coordinates for this point would be the x would be 1, y would be 10, so you'd have coordinates of 1, 10. Okay? So you pick 2 different points on the line, so if we picked 1 and 10, we could also pick 2 and 20. So you look at the y coordinates first. The y coordinate is a position that occurs more rightward, the y2 coordinate is a position that occurs more rightward on the graph than the y1 coordinate. So if we used 1 and 2 and 10 and 20, If we look here, this is one of our y coordinates and this is the other. So y2 is the one that occurs more rightward on the graph. So this point occurs more rightward on the graph than this point. So our y2 would be 20, meaning our y1 would be 10. We do the same thing with our x coordinates. So we have a point of 1 and 2, or an x of 1 and an x of 2 for two different coordinates. The x2 always occurs more rightward on the graph than the x1. So again, our x2 would be 2 and our x1 would be 1. Okay? So then you determine the difference between the coordinates. So looking at your y coordinates, you would take y2, subtract y1, which up here we can see is also equal to rise. And then you do your x coordinates on the bottom of your equation. So your x2 minus your x1. So in this example, we would have 20 minus 10, if we filled that in here, and we would have 2 minus 1. Okay, so then you just divide out this equation, and you have your slope. So I've written out these steps in a little bit more of an equation style formula for you. So the steps coordinates, you write out your coordinates, x1 and y1, x2, y2, write out where your y2, y1, x2, x1 are, and then you can fill them into your formula, and make sure that you answer with the correct direction, whether it's positive or negative. So let's take a look at some examples of those. So here on this graph, this is what our graph would be. We'll take our coordinates. So I chose point 0, 0 as my x1 and y1 because it's closer here. And then I chose my x2 and y2, which is more rightward on my graph, to be a point of 3, 30. Okay, so my y2 I wrote down here, so is 30, my y1 is 0, my x2 is 3, and my x1 is 0. So I wrote out my formula just to be sure, filled in my formula. I did my 30 minus 0 because it's my y2 minus my y1, and then I wrote out my 3 minus 0 here because of my x2 minus x1. So that's how I get my 30 divided by 3, and 30 divided by 3 is positive 10 meters per second. So we would know that the slope of this line would be positive 10 meters per second, which also means that the velocity this object is traveling at is 10 meters per second in the positive direction. So just note, it's fine to have a negative answer. This means that the object is traveling in the negative direction. So lots of times we get really worried thinking, oh, maybe I did this wrong. If your line is going in the negative direction, then you would have a negative slope and have a negative velocity. So we'll look at one example like that. So again, let's look at our coordinates. So my first coordinate is going to be 0, 4, and my second coordinate I chose as 10, 0. So my x2 and y2 were farther or more rightward on my graph. So again, I wrote out my coordinates, and I wrote out my y2, which is 0, my y1, which is 4, my x2, which is 10, and my x1, which is 0. So wrote out my equation. Again, it's always good to write out your equation. Make sure that you're showing your work so that I can see what you're doing and you know what you're doing. So let's look at our y2. So y2 is 0 minus a y1 of 4. And then our x2 of 10 minus our x1 of 0. So I have minus or negative 4 divided by 10, which gives me a negative slope of 0.4 meters per second in the negative direction. So that means we just have a negative velocity of 0.4 meters per second. Again, negative velocities are fine. It's completely what the graph is telling you. So if you see a graph with a slanted line in the negative direction, you know that you should be getting a negative slope. And if anytime you don't have a graph but your numbers are coming up negative, that's completely okay. It's just based on if your object is traveling in the positive or the negative direction, right? Right on. So here's a practice example. You can take a look at that and give that a go. So the other thing we're going to talk about just really briefly today is the interpretation of position time graphs. So we have, this is going to be kind of a combination of calculating slope, which we learned today, and understanding position time graphs. So if you ever had a graph that looked like this, you would be able to look at this and tell me what is happening on this position time graph. So for this example here, there's a little story that's been written about it. So it says, a dog trainer throws a stick, the dog chases and covers 15 meters in 3 seconds. So we started at this point of 0 times 0 meters, and then the trainer threw a stick, so we got to a position of 15 meters, and that took 3 seconds. These lines look like they're a little bit crooked right now, but that's okay. We know that this is 15 meters because we have a position of 15, and that took 3 seconds to get there. Okay. It then says a dog sits on command 15 meters away and waits for the trainer for 3 seconds. So we know this position isn't changing, so we count 1, 2, 3 seconds, and we stayed at 15 meters, so you would draw the straight line across. It then says the dog approaches 10 meters in 2 seconds, so we knew that the dog ran away and then came back, so we go from 15 meters to 5 meters because that's a 10-meter difference. So again, we have to do everything in relation to where we were. So 15 meters away and then moving 10 meters, we know that we're moving 10 meters from this 15-meter point. So this would be 10 meters, making us at a position of 5 meters away. And this tells us that it took 2 seconds. We then sat and waited for another 2 seconds. So if the dog sat and waited for 1, 2 seconds, it's not moving. The dog then comes right to the trainer's feet, so all the way back to our position of 0, and then waits for 2 seconds. So this is a little bit tricky. I would recommend that you go over this a couple of times so that you understand the wording of moving away from, moving towards. So if an object is moving away in the positive direction, it'll be going up, and if it's moving towards you, it would be coming back down on the graph. And then again, everything is in relation to the last point. So if we started at a point of 0 and traveled 15 meters, which we had talked about, and then sat and waited, and then traveled back 10 meters, that 10 meters is in relation to this point. So we're traveling back 10 meters. Okay, so take a look through that, and then there's an example here for you to write out a story. So make sure you're noticing in this story that this is a position of 0, that whatever you're going to make your story about is traveling up. It then goes past that point, okay? So past a point of 0. So you would be traveling in the negative direction. And then this little point here, and this one as well, these would be traveling in the positive direction because they're going upwards on our graph. So they're moving in the direction, in the positive direction, even though they're in this kind of negative area, okay? So it's all about what direction the lines are going on a position time graph. So if they're going up and to the right, you're in the positive direction. If you're going down and to the left, not down and to the left, if you're going down and to the right like this, then that would be in the negative direction.